solving this quadratic is going to be one of the more complicated ones because we are going to factor it and then we are going to solve it using the zero product property. Now, if I move too fast on here, I do have a whole other bunch of tutorials on my YouTube site about factoring and solving quadratics and taking greatest common factors and things like that. So please feel free to kind of cruise around, do a search, whatever helps, but I will go through this step by step, hopefully, and hopefully that works for you. So we're going to once again identify A, B, and C. A is 2, B is 4, and C equals negative 6. So the first thing we're going to do is multiply A times C, which is going to give us negative 12. So we're looking for two numbers that multiply to negative 12 but are going to add to B, which is 4. Okay, so we're going to start easy. 1 times 12, then 2 times 6, 3 times 4. Those are the only factors we've got. And what I'm going to do now is I'm going to, since these do multiply to be a negative, I know that one of them has to be negative. So I'm going to look and see if there's one where if one of them's negative, they add to positive 4. Well, if 1 and 12, there's no way that they could add to 4, no matter if one of them was positive or negative. 2 and 6, though, if my 2 was negative, 6 minus 2 is 4. And 6 times negative 2 is going to give us negative 12. So I think we've found our solution here. Now, when I say our solution, we're still kind of far from finding an actual solution. But what I'm going to do is I'm going to take this middle term and I'm going to split it up into these two numbers that we found with those coefficients, but with an x. So I'm going to change it to negative 2x and positive 6x. Okay, so I haven't really changed any values because if I wanted to, I could recombine those middle two terms. They'd still make 4x. Nothing is different. What I'm going to do now is I'm going to split this in half. And I'm going to now factor out the greatest common factor of each side separately. So when I look at the left-hand side, the greatest common factor between 2 and 2 is 2. And then how about x squared and x? Well, they both have an x in them. So basically what I'm going to do is I'm going to divide both of these by 2x. All that'll be left in the first term is just an x. And the second term, the whole thing would cancel out, leaving us with 1. So I'm going to do x minus 1 because that negative would not cancel. Let's do the second part. Greatest common factor of 6 and negative 6 is 6. And if that front term was negative, I would factor that negative out. But in this case, we don't need to. And that's going to leave us with x minus 1. Now, hopefully you guys noticed that this, whoa, that was a little bit larger than I intended. This and this match. That's right. That's a good sign. That means that you're probably doing something right. So now, what I'm going to do is I'm going to write that x minus 1 because that is one of our terms, one of our binomials, one of our factors. And then whatever is not inside of that parentheses, the 2x and the positive 6 is going to become our other factor. And it still does equal 0. So now is when we're going to take out our, zero product property skills from our previous video. So that x minus 1 equals 0 and 2x plus 6 equals 0. And we're going to solve those separately. And x is going to equal 1. Sorry about that. X is going to equal negative 3. Those are my two solutions. I can plug them back in. They're going to yield an answer of 0, which is what we're looking for. That's why we're going to call them the zeros. Hopefully that tutorial made sense. If you do need additional support, please look for it. It's in there. Thank you.